Hello folks, this is video number 6 on using the Catia's native FEA solver to handle some composite problems, which are developed in Catia itself. Now, in video 5, I did a few things on basic stuff on creating plies manually, and that's fine. But I would like to extend that today is by the concept of importing a ply table and quickly changing it, sending it back to Catia, or uploading it back to Catia to modify the properties. Uh, the problem that we're going to be doing, the geometry is the same. It's made of basically two patches. One of them is going to have a stacking sequence of laminas, as shown on the right side here, 45 minus 45 minus 45 45, and this is all made of Kevlar from the Catia database. And the rectangular patch is two layers or two laminas, two plies, 90 degrees each. Okay, and this is loaded in the x direction along that edge and clamped on the other one. Now, uh, first of all, you do realize that because these are two different patches basically, I have to create the surface so that it's got these patches identifier on it. Okay, so here's my approach. So let me go ahead. This is my part file. Immediately I save it. File, save management, save as. Let me see now, desktop. My desktop. I made a folder here. Import ply. Say OK. All right. So let's go ahead and create the 50 millimeter by 50 millimeter patch. First of all, we switch to generative shape design. On this horizontal plane, I will sketch a rectangle which is 15 millimeters by 15 millimeters. There are different ways of doing this problem as far as the geometry is concerned, but this is how I'm going to approach it. 50, and another one on the side, also 50. Say OK. We exit. Okay, and I'm going to fill it, FIL, right there, and I'm going to join it. Good. So let's go and do exactly the same thing. Another rectangle on that same plane. So on that horizontal plane again, sketch. As I said, please make sure you do it your favorite way or any way that works. But this is my approach, which may not be the most efficient way of doing it. So I'm going to make this point coincident with that point, and then I'm going to give a dimension of 100 millimeters there. Exit, fill it, join it, join this particular segment. I'm not joining these two, okay? Good. Now remember that when you join, you have a direction associated with the join. So I'm going to flip that so it goes down. The same thing is flip this thing so that it goes down. The reason I do that is the direction of this arrow is opposite to the direction of the shell element, normal to shell element, which I want it to be up. Okay, good. So let me create a coordinate system on this corner because I want to use that as rosette later on. Let me see now. I think I've closed that particular window, so let's go ahead and do this. Tools, options, customize. this can also be done later on in the composite design workbench, but I'd rather do it here. Tools, restore all, and restore position. Okay, so where is my, right there. This is the toolbar that was closed. I couldn't find this fellow, okay? So let's do that. Click on it. Now, when you do this, the coordinate system is immediately created at the global origin, which is right in that corner, okay, and aligned with the XYZ. Now, I want this thing to be shifted a little bit to the left, so I say put the cursor in this origin box, create a point, and I'm going to put a minus for Y. I'm going to put minus, I don't know, maybe 30. There, it's going to be created there. Very good. Okay, so we are all done here. So let's go ahead to CP composite design workbench, mechanical design, composite design. Right away, we're going to create our composite parameters, and for material, add a material. I'm going to use Kevlar. You click on this. I'm going to go to the Catia's default database on composites, load it up. I'm going to scroll down Kevlar. Okay. And then OK. Incidentally, if you want to know the properties of the Kevlar that are used, the only way to do it is to go here let's see now, we go to File, Desk, it's right there. Right click, Open. The default database opens up, and there is Kevlar 4. You can double click on it and select the different tabs. So these are the default uncued thickness or cued thickness 0.2. The material properties are given right there. So cancel and cancel. This is okay. This is a read-only file. So if you want to have your own properties, then watch the video number 2 and 3 where I create user composite properties. Okay, so let's see now. All right, now as far as let me double click on this thing again. The default orientations that I have are these, and these are sufficient for the original one that I want to create. Otherwise, you add your own. Okay, and in the next video, and maybe in 2 video segments, I'm going to be talking about laminate, the concept of laminate. Cancel. Okay, now we're going to create manually, just like I did it in videos 2 through 5, the plies. So I need 2 ply groups. There is a ply group. See this right here? Oh, you know what? One thing I forgot to do, I forgot to select my rosette. So let me go back here. There was a tab here, rosette, and add a rosette, and that corner system that I created. I could have done it later on, and make sure you hide it. This is distracting. So a rosette. Oops. Oh yeah. Say OK and OK. So now we have also created a rosette. Okay, so let's go back here. We're going to create 2 ply groups. One of them is going to be this surface, and I'm going to flip the direction up so that all the plies that are created align with the direction of the arrow. Lock it. That's locked. And for rosette, I'm going to select rosette 1, and that's it. This is the first ply group. Then I'm going to do another one. This is the surface. Flip the arrow up. The direction has been locked. And for rosette 1, and we say OK. OK. Now we're going to go and create our plies. OK. So ply. Bottom left corner, it says select a ply group or a sequence, etc. I want this ply group. OK. Now, Uh, the contour, for the contour, I select this first sketch that I had here. See that? That little small rectangle. And for attributes, I'm going to Kevlar, and the direction of the first one was red, which is 45, okay? So 45, not minus 45, 45, okay. Notice that the first one is created. Now for the other ones, I can do exactly the same thing 4 times, or I can copy this ply and paste it in there. But I'm going to do it again, just like I did before. In that ply group, the sketch, and minus 45, okay? And then again, the sketch, and minus 45, that's good. And for the fourth one, 45 degrees. Okay, now let's go and do the second ply group, which is two 90-degree plies. So ply group 2 sketches this bigger one right there, the bigger sketch, and this is 90. Okay, and another one, ply 2, the sketch for the bigger rectangle, and also 90. Very good. Why don't we save everything here? Points to be modified. Let me see for a second here. That's good. File, save management. This one, save, and okay. That's fine. The reason I got that message is that I went to that Kevlar properties, and somehow it's, I think it's probably, yeah, so that's why I got that message. No problem. Okay, now in fact, you can check your stacking sequence here. So you go here, apply exploder, right there, you can see that, apply exploder. Apply group 1, apply. 45 minus 45 minus 45, 45. And for the second group, 90 and 90, okay? You can do them at the same time. Okay, very good. Now, we're gonna save this. I already saved it. Okay, so here's the situation. Suppose you wanted to change these. Suppose you wanted to change these to a different configuration, angle configuration, configuration, or even different materials if you want. So one way is to go there. One way is to go there to each of these plies, double click, change the direction, change the material if necessary. The other way to do it is the following. You say, okay, let me write, you see that right here? Ply table, see this? Ply table. See the title, it says, use the ply table, and then later import, okay? So, you go there, it says, okay, you have two groups here. Would you like to create an Excel spreadsheet or a text file if needed to put the information about these two ply groups in it? So one of them or both of them, I say both of them. Then it says, okay, where do you want to put it? Well, I'm going to go to that folder that I have, basic stuff. I'm going to give it a name. So it says my table, my table. I'll say my generated table. Okay, and we say okay, and then it says, do you want me to open it after you create it? The answer is yes. There we are. So a table has been generated, Excel spreadsheet has been generated in my directory that I specified, which gives the information about these plies. So right there, and material, direction, etc. I can go and change these in the order that I want. For example, when you look at group one, there's 4 of them. This is what I did, and I want to change those to uh, minus 45, 90, 90, etc. So you go here, you go to that table, you can change this thing to minus 45, this one to 90, oops, minus 45, this one is 90, next one is 90, next one is minus 45, and these two, I don't know what they were, let's check it out. These two are still remaining as, the first one is going to be 0, the second one is going to, the first ply in that group is going to be 0, the second one is going to be 90. So we go there, this one is going to be 0. Okay, good. Do not fool around with these things. Okay, if necessary, you can change the material, but I'm going to leave it like that. You can also change the, if you want, you can change the numbering here. I don't know why you want to do that, but in case you don't want this, let me show you. You can, for example, choose a different numbering sequence for it. You don't have to do it. Don't try to enforce it. Look, right there. See that? Good. Changes the names. Okay, so save it. Let me undo this thing, put it back where it was. Well, actually, that's fine. Let's see what happens. I'm going to close that. Okay, now we already created that. Now we're going to import it. See, this one, it says import table, ply table import. You go there, you go to that folder. This is the one that I generated. You say okay, and we move on. There, you see, you changed, simply changing that Excel spreadsheet, your directions. And if necessary, you can find the orientation. Even the ply numbers, look, 001, 002. Anyway, this is this export and import ply table is very useful. You don't have to march through these, through these things. You can also reorder the rows of that, change. Yeah. Okay, good. Now, let me save this because I want to show you a few things. Okay, so let's go ahead and do an analysis of this thing that we created. So uh, we'll get to that in a minute. So we're done here. As a matter of fact, I can go ahead and delete that entire figure here, or exploded view. All right, good. Now we're going to go to advanced meshing tools, because I want to use a fancy mesh, a rectangular type element. Okay. This is a surface mesher. I don't want to use the ugly mesh triangular one. In order to do that, you don't have to come here. You can go directly to generative structure analysis. Surface mesher, that's the one. Arrow points up because the direction of the joint was down. Now, I want a parabolic, rectangular, only rectangular or quadrangle, size 10 millimeter. I will come back and talk about this automatic mesh capture again. So automatic mesh capture within 1 millimeter, right? So we say okay, and mesh it, and zap or exit. This is mesh, 10 millimeter by 10 millimeter. You can display the mesh, but that's okay. Now we do the other one, this one, 10 millimeter. Now automatic mesh capture. So any nodes that are within 1 millimeter of another node, they're going to be merged. So right now you have a bunch of nodes on this side, which was generated already. Now there's going to be nodes on the left side, but because those nodes are going to be within 1 millimeter of the ones on the right, they're going to be merged into single set of nodes on the on the on the on that edge. Later on, I will come back and uncheck that and show you that it's going to be a disaster. The two are not talking to each other, and exit. Did I mesh it? I can't remember. Did I actually mesh it? Let me see for a second. Yes. Okay, we are done here. So we're going to go to generative structure analysis. And if you want to be 100% sure, put the cursor there, right click mesh visualization, and change the rendering. Third one. So if you zoom in, you see that that line was here, and if you look at nodes elements on both sides, they have the same node numbers. If I had not merged those nodes, there would have been different numbers on the two sides, and these nodes are not talking to each other unless you create some kind of a constraint between them, and the software is going to fall apart, or the run is not going to be successful. We'll see that. I'll do that for you later on. So we go deactivate. Okay, so then we're going to do our boundary conditions. Now, in order to do that, notice that here there's a bunch of curves. There are the plies, ply edges, there's the sketch. So I have to deactivate those or hide them, not deactivate, hide them. So you go here, stacking engineering is going to be hidden. There's still these sketches here. So those are the sketches from the rectangles that I drew. So I'm going to hide this, and I'm going to hide that. Right now, when I select this edge, it's going to be that black line. Okay, so we're going to clamp that. I think that was that was clamp. That edge is clamp. And on the right hand side, I'm going to put 10 Newton per millimeter. That's a huge number. That's 10 Newton per millimeter is 10,000 Newton per meter. That's a ton. That number is too big. You see this number? Where is this? This number, I'm going to change that Newton. Well, we'll find out. This is going to give you a big displacement. I don't like it. In fact, we'll see. Okay, that's one reason you're doing finite element. You don't know what you're going to be getting. It can be done with hand calculations. So now we have to import our composite properties. So here, import composite properties. The support, we have to do it twice, one for this basically ply group, and then for the other ply group. So the surface is here, ply group, we're going to go, and it was ply group 1, I believe. Yeah, ply group 1. Okay, I will keep this symmetrical as check. Then another one, this is the surface, this is the support, ply group, and ply group 2. And once again, I'm going to check it. Now, so when I have both of these checked, means that these two plies are going to be symmetrically placed about the middle or the reference surface. This is my reference surface. And when you say symmetric, means that take this and symmetrically place it there. And if this is checked, take this and symmetrically place it there. And then clamp this edge and pull it. Okay? Now, by the way, because this is not a symmetric stack, uh, this will actually bend. Okay, this will bend. They will be out of plane. As you will, when I run it, you'll see it. You'll see that. But if this was blue, or if these were the same colors, it would be a symmetric laminate, and therefore when I pull this thing, it's just going to stretch. Okay, and possibly shear. I mean, if it's balanced, it's not. This is not balanced, then it will shear. But anyway, now on the other hand, if you go, for example, and say this one is checked, so it's symmetrically placed at the bottom reference plane. This is unchecked, means that place it like this. Or here's the other one. If neither one of these are checked, so the laminate that we're looking at is going to be like that, and we are pulling on the edge of this particular this lamina and then clamping that. So obviously it's going to be out of plane. But no, I'm just gonna use both of these check. I think we have everything. So we run it. There's going to be out of plane deformation here because of the fact that this lamina is not symmetric. Okay, so let's see. Where is the deflection? Ooh, oh, I forgot to put the load. No wonder. Okay, so let's go put the load here. Let's check this. I forgot to put the load on it. No wonder we got zero stresses, zero displacement. So let's see now. Deactivate this. Okay, the load is right here. I'm going to put load density, line force density. So on that edge, in the direction X, I put down 10 Newton per millimeter is 10,000 Newton per meter. That's gigantic load. So we say, okay, now we're going to run it. And it's going to be huge displacement. 41 millimeter displacement out of plane, obviously. Okay, so that actually that 10 Newton per millimeter is too big in view of the thickness of the laminate and the way this is arranged. So, but anyway, that's not really the point of this exercise. I wanted to show you how to use the import ply table to make easy changes on the uh, on your plies. Okay, now what I'm going to deactivate that and go back here. Go back here. Remember, I said that this is important. It's important to say merge the nodes, mesh capture as they call it. If I uncheck that and say OK, then this square patch is going to be remeshed without actually taking merging into consideration. Okay, uh, and I have to do the same thing with the other one, which was, I believe it was this one. That one is done. The other one, uncheck it, say OK, mesh it, and exit. Now, if you say show me the mesh, right click mesh visualization, change the rendering to this. The line that I had, the separation line was here. Look, when you put the cursor on this side, this node 27 is on that line. When you go to the other side, the node is 156. These are separate nodes. This is why when I try to run this thing, it will bomb out. It will not finish. See, it says singularity detected, basically cannot solve the problem. Now, you can, none of the displacement or stresses are correct. In fact, you cannot even plot them. But if you plot the deformation, you can see what happened right there. You can see that there was a seam there that it did not know that is what it's subject to rigid body motion, and Catia cannot predict the overall displacement and stresses. Okay, so I will repeat this problem or something similar to it using the concept of uh, zone method, and we'll see. Good luck.